If you've ever died in the first minute of a workout, this is why. This is a Wingate test, and it measures your anaerobic power. What do I mean by anaerobic power? Well, when we do workouts, we get energy to do those workouts from one of three places. Number one is the phosphocreatine system. Think back to high school biology. Do you remember what ATP is? ATP is the energy currency of the cell. It powers your cellular functions. It's the reason we can do, well, basically anything. In the muscle cell, we have phosphocreatine and we have ADP, adenosine diphosphate, which means it has one less phosphate than ATP, adenosine triphosphate. In the first 10 seconds of really intense exercise, we need ATP and we need it now. So phosphocreatine is going to donate a phosphate to ADP, and that's going to make ATP. And yes, this kind of system is the reason why we supplement creatine, but that's a whole nother video. This system gives us energy fast, but the problem is it only lasts 10 seconds. I'm going to take a guess that your workouts last longer than 10 seconds, so we're going to have to find another method of creating energy. Anaerobic glycolysis. Have you ever heard me say that I like to eat candy before CrossFit competitions?
First, I had to eat some Sour Patch Kids before I spent the next 15 minutes eating the floor.
This is why. Your body can take glucose, aka sugar, and in a series of really fancy steps called glycolysis, it can use it to create energy in the form of ATP. The thing is, glycolysis also makes something called lactate. It's typically thought of as a wasteful byproduct, which is not entirely true, more on that later. But we can use blood lactate as an indirect measure to determine how much power we can produce and how quickly. If your training involves a lot of short sprinty stuff, your body is used to using this pathway, and thus you're going to have higher blood lactate than your friend who runs marathons. And no, that's not a diss on your friend who runs marathons. They just use a different energy system than you. So here I am volunteering as guinea pig to get my blood lactate tested before I hop on the bike. It's done via a little poke in the finger. My resting blood lactate was 3.2 millimoles per liter. We head over to the bike. Now here's how this bike works. We have to have a calculated amount of resistance. That number is 7.5% of my body weight. Here you can see this allotted amount of weight added to this basket. The basket gets magnetically clipped up and out of the way, and I start pedaling. Once I'm pedaling as fast as I possibly can, I press a button on the handle and that releases the basket and adds resistance to the bike. Then you just pedal your little heart out while your classmates scream and yell at you to go faster.
Come on, let's go. Come on, harder, harder, harder. Go, you got it. Come on, you got it. Let's go.
The idea here is to reach lactate threshold in about 5 to 10 seconds. Lactate threshold is the point where your body is producing lactate faster than it can get rid of it. So essentially, I'm trying to produce as much lactate as fast as I can, and it doesn't feel very nice.
3, 2, 1.
While one classmate checks an immediate heart rate, the other one pricks my finger for a post-exercise lactate reading. It really does take a village to do this test. My heart rate here was 181, which doesn't surprise me. I hate cardio. My blood lactate was 6.0. So we actually had 2 people from our group do this test. I was supposed to be on passive recovery, which means I was seated in a chair for the next 20 minutes and doing nothing, but we had another student do active recovery, which was 20 minutes of low intensity cycling. Over the next 20 minutes, we checked my lactate and heart rate every 5 minutes. Here we can see at the 5-minute mark, my lactate has climbed to 15, climbs again to 17 at 10 minutes, and just sort of stays high. Pretty interesting when you compare it to my classmate who was doing active recovery. Hers was also around 15, 5 minutes post-exercise, but it comes down much faster. Without going into detail, active recovery helps clear lactate from the muscles and the blood, and yes, this is a good thing. The blood lactate part is really cool, but what we also want to look at is power output. This is automatically measured for us in watts, and the numbers pop up on the screen over the duration of the 30 seconds. Here we can look at peak power output, the most amount of power we can produce, as well as mean power output, which is the average sustained power over the duration of the 30 seconds. We can also look at these two things relative to body mass. Because I am a very small person, I won't be able to produce as much power as my class. Basically, we're measuring how powerful are you for your size. Because I am a smaller person, my absolute peak power output is smaller than my classmates. But when we accommodate for mass difference, my relative power is slightly higher. This means I might have the upper hand in something like a 1-rep max powerlifting comp.
Great! Come on, get up! Yeah!
assuming there are weight classes. But if we look over here at fatigue index, my classmate's fatigue index is significantly lower. And this is important because it means that she can sustain her power much more effectively than I can. While I might be better at maxing out my back squat for 1 rep, she's going to be better at doing a large set of back squats over a longer period of time. So to summarize, the Wingate test tells us how much power we can create without the help of oxygen and how quickly. I wouldn't recommend it. 1 kid threw up.